Greetings, ladies and gents, and welcome back. It's Mike Maths and Science Club. In this video, we're looking at a question which was written in November 2014. It's a question on vertical projectile motion. So, question 3, they said that a ball A is thrown vertically upwards from a height h with a speed of 15 meters per second. They say that at the same instant, at the same time, a second identical ball B is dropped from the same height as ball A, as shown in the diagram below. They say that both balls undergoes a free fall and eventually hit the ground, right? So in this case, for 1.1, this is that define the term free fall. Now, the term of free fall is actually motion during which the only force acting on the object is the gravitational force only. So that's your definition, your formal definition for free fall. So free fall is a motion during which the only force acting on the object is the gravitational force only. So that's your definition for 1.1. So for 1.2, they said that calculate the time it takes the ball for ball A to return to its starting point. So in this case, of course, we have ball A there. So what would happen is that, of course, so what happened is that, of course, they projected this ball upwards. So in this case, it reached its maximum point at that point there, and in this case, it returned right there before, of course, it passed, of course, going in the other direction. Right, so in this case, they're asking. So what I'm going to do, I'm just gonna label my points. Right, so I'm gonna label that as A. That the starting point is point A. That would be point B. That would be point C when it returns at the same point. At the same point, right? So in this case, that would be point C, and I'm going to have another point there to be point D, and the ground to be point E. So in this case, they said that calculate the time it takes for ball A, right, to return to its starting point. So in this case, they want the time taken by the object, by object A, to, in this case, to reach in this case point C. Right? So in this case, so what you're going to do would be to say between point A and C. So we know that force V initial equals to, so we know that, so what I'm going to do again, I'm going to choose upwards as positive, so downwards in this case would be, in this case, negative. So in this case, my velocity initial for ball A would simply be, in this case, 15. Then in this case, remember that, of course, these 2 points actually, those 2 points, we said that, of course, when in the previous lesson, so we said that these 2 points actually points of symmetry. So we know that, of course, the speed on these 2 points in this case is actually equal, but in this case the only difference would be the direction of the speed. So in this case, that would mean that, of course, the speed at point C is actually 15 meters per second, but in this case downwards, right? So in this case, that would mean that in this case the speed at point C, which would be in this case Vf, which is V final, it's actually equals to negative 15. So in this case, now remember what we also said, of course, in the previous lessons that we did, right, on vertical projectile motion. Right at the beginning, we said that, of course, the time taken by the object to travel between point A to B, right, so that the object actually take the same amount of time to travel between point B and C. So if I know how long it took the object A to travel between point A and B, so in this case, to determine the time that it took to travel between point A and C, I just simply take that time, right, and multiply it by 2. But in this case, what I'm simply going to do would be to choose these points. Why? Because in this case, I actually know the velocity initial of that point, point A, know the final velocity, and in this case, I'm looking for time, so I'm going to leave that as is. Right? But in this case, also in this case, that is displacement is actually equals to 0. Why? Because in this case, point A and C are exactly the same point. So in this case, the displacement there would be 0. Right now, I don't know if you want to keep that to be negative 0 or 0. I'm just kidding, right? So in this case, so A, right, will simply be, in this case, negative 9.8. So in this case, so we are looking for the for time. So any equation that we are going to choose there must actually have, in this case, must have time. So in this case, let me just, right, so in this case, there's our formulas. So in this case, of course, let's see, this equation, of course, not going to be applicable, right? But in this case, so in this case, the rest of the, of course, of the equations there, they're actually going to be applicable. But in this case, what I like to do is just to make things easy for myself. So I'm simply going to choose that first one. So in this case, simply become Vf equals to Vi plus A delta T. Right, so in this case, Vf is actually negative 15 this case my vi would simply be equals to 15 plus negative 9.8 multiplied by delta t. So in this case, in this case, if I take this that side, so it simply become negative 15, and negative 15 minus another negative 15. So that would mean that in this case, this simply become negative 30. So it will be equals to negative 9.8 multiplied by delta t divided by delta t on both sides. You find your delta t to be equal to, in this case, 3.06 seconds if you round that off seconds. So in this case, this tells us that in this case it took this object A 3.06 seconds to travel between from point A all up, in this case, until point C. So in this case, so from this at the time that we got here, we can actually just determine from that point how long it took the object to travel between point A and B. So in this case, what we can simply just do there would be to take that time and divide it by 2. That's the time taken by the object to travel between point A and C, divided by 2. Then in this case, you'd know how long it took to travel between point A and B. So in this case, simply be, in this case, t between point A and C. So in this case, delta t. Now this is just me preparing for the future. So in this case, between point so in this case, the time between point A and B would simply be, in this case, this time divided by 2. So this simply become now, so t between point A and B, how long it took object A to reach its maximum height. So in this case, simply be, in this case, 3.06 divided by 2. Actually going to get that to be 1.53 seconds. Right, so that would be a time. That's how long it took to travel between point A and C. Now this is out of the question, right? This is just me preparing for what I'm gonna do next. Right, but in this case, this simply be, in this case, for that 1.2. So this simply be, in this case, your 4 marks there. So in this case, for 1.3, this is that calculate the distance between ball A and B when ball A is at its maximum height. Now remember that in this case, these two objects were projected at the same time. So that would mean that in this case, at any given point, right, as long as these two objects are still in motion, so that would mean that their time in motion will simply be, in this case, at the same. So if in this case object A has been in motion for 3 seconds, so that would mean that in this case object B would also be, in this case, in motion for 3 seconds. But in this case, this is only applicable for as long as both of them are still moving, right? But in this case, if one is stopped, right, when one has reached the ground, we can't in this case predict that. But in this case, for as long as they're still in motion, if they were projected at the same time, so that would mean that in this case their time in motion, right, for at any given point, for as long as those the two objects are still in this case moving, so in this case their time will simply be the same. So if I know time for ball A, I would actually know also the time for what, for ball B. Now in this case, they say that calculate the distance between ball A and B when ball A is at its maximum height. So right, so in this case, what I'm simply going to do, I'm simply just gonna draw again this graph, so that in this case I can in this case you can be able to answer that 7 mark, even though I feel like it's gonna be hard. But anyway, let's see if it's gonna be that difficult. So in this case, we have ball A. So in this case, they want the distance between ball A and B, but in this case, when ball A is at its maximum, in this case, point. So in this case, remember that, of course, when object A was projected upwards, so in this case, at the same time, object B was, in this case, traveling, in this case, downwards. So in this case, what they want would be the distance between ball A when ball A is at its maximum height and ball B. So in this case, let's say ball B is at this point, right? Let's say it is at this point, and I'm just predicting. So in this case, it started from that point. Let's say it is in this case at that point. So in this case, we say this is point A, this will be point B, this case will be point C. I'm going to label this to be point D. So what they want is simply the distance between point in this case B and D. Now in this case, what I'm simply going to do would be, now remember that, of course, they say that they want the distance between ball A and B when ball A is at its maximum height. So in this case, what I'm simply going to do, so in this case, according to what I did there, I actually know how long it took object A to reach in this case point B. So that would mean that in this case, it also took we said that that is actually 1.53 seconds. So that would mean that in this case it also took the second object, this object B, 0 point in this case 1.53 to reach that point at D there. Why? Because in this case we said that in this case whatever time at any given point, whatever time that object A has in motion, so that would mean that in this case object B would also be in motion for that same amount of time. So in this case what I'm simply going to do would be to calculate in this case how far below the building was in this case ball B in this case after that 1.53 seconds. So in this case what I'm simply going to do would be to say that between in this case between point C, right, and D, I'm just trying to calculate in this case how far below the building this object the second object was in this case after in this case 1.53 seconds. So in this case what I'm simply going to do would be to choose my points between A and D. So in this case I know that of course this second object object B was actually dropped, meaning that its initial velocity is actually 0, right? So in this case what I'm simply going to do would be to say that Vi is equal to, in this case, equals to 0. Vf, I don't know that what speed, I don't know at what speed it was traveling. In this case T equals to 1.53. So in this case I'm going to leave that as is. So that simply means that in this case for time we know that's actually 1.53, and in this case the displacement, that's actually what we want, right? We want to know how far above the ground that object was displaced. So in this case I would actually know this height, right? So in this case I don't know that, but in this case our A would simply be equals to negative 9.8. Why? Because in this case we chose downwards is negative, and in this case we know that A is actually always downwards. So in this case what I'm simply going to do again, right, do we have our formulas there? Let me just bring our formulas again. Right, so in this case that's what we have there. So in this case we are actually looking for displacement, but in this case we don't have the final velocity. So any equation that we're going to use mustn't have the final velocity. So in this case this can't work. Why? Because in this case it has final velocity and we don't know it, and also this one is not going to work, but this one however is going to have is going to work, but in this because in this case we don't have in this case the final velocity there, but in this case at the same time we have time, which is we have actually that displacement there, which is what we are looking for. So any equation that we're going to choose must have displacement, what we are looking for, and mustn't have in this case the final velocity, because we don't know the final velocity of the object is there. So in this case what I'm simply going to do would be in this case to choose that that third equation there. So in this case that would mean that let me just erase this again. So in this case that would simply mean, no, I made a mess. So in this case that simply mean that in this case my V initial, say that V initial actually delta x would equals to in this case Vi multiplied multiply that by delta t plus a half multiplied by A multiplied by t squared. So in this case what I'm simply going to do there would be to substitute. So in this case my V initial for ball, so this would be in this case for ball B, right? So this is for ball B, so in this case would be for ball B, right? So in this case Vi, we're given that, so that's 0, multiply that by 1.53 plus a half, multiply that by in this case negative 9.8, multiply that in this case by time, which is 1.53, square that. If you put that into your calculator, the value that you're actually going to get is actually negative 11.47041. Now I'm not going to round it off. Why? Because in this case this is not the final answer. So this simply tells me that in this case 8 time equals to 53. So in this case the displacement of object B is actually that negative 11.47041. So in this case, so that simply tell me that the distance between point C and D is actually what? It's actually that 11.47. So that simply tells me that distance between point C and D simply equal to 11.47041. So in this case what I'm also going to do would be, now remember that to determine the difference in this case the distance between these 2 points, so in this case I would need to know how far this object was displaced, how far the second object was displaced, right? In this case time is equals to 1.53. So in this case if I know that in this case that distance there, So in this case, what I can simply just do also would be to calculate that distance there, and in this case I would simply be able to know that whole distance there. So in this case, what I'm simply going to do now would be, in this case, to calculate the how far above the ground, right, how far above the building ball A, in this case, was 8t equals to 53 seconds. So in this case, what I'm simply going to do would be, in this case, for ball A, just take another color there. For ball A, I'm going to say that I'm going to choose between point A and B. So that will mean that in this case, because they want to know the distance of the objects, the distance between these two objects, when in this case object A is at its maximum height. So in this case, I know that between point A, I know that A, in this case, velocity at point A simply equals to, they said that's 15. So Vi would simply be equals to 15. In this case, my Vf, right, which is velocity final, be 0 at the maximum point. Then in this case, delta T simply equals to 1.53. In this case, delta X is what I'm looking for, right? So in this case, I know that A simply equals to negative 9.8. So in this case, again, you notice that in this case, but for this one, we can actually use any equation that has displacement. So in this case, we can't use this one. This one we can use. All right, we can also use that one, because in this case, we know the final velocity, we have the initial as well. We're just looking for, in this case, for delta X. But in this case, what I'm simply going to do would be to choose that one. And my reason for that is because you actually already have delta X isolated there. You can also use that one, but yeah, simply going to use that one. All right, so in this case, that simply mean that in this case, I'm going to say that V delta X, let me just write that, delta X is equals to, in this case, a Vi multiplied by delta T plus a half, multiplied by A multiplied by A multiplied by delta T squared. So in this case, simply be equal V initial, so that's actually equals to 15, right, positive 15 time, that's 1.53, right, plus a half multiplied by negative 9.8 multiplied by 1.53, but you square that, and if you put that into your calculator, you're actually going to get 11 point, that's actually 11.47 7959. Right, again, we can't round that off. Why? Because in this case, this is not actually the final answer. So this will simply be, in this case, the distance. That's meter. This will simply be the distance. This case between. Let me just say between, in this case, point A and P. So in this case, it would simply be equal to. So you know that the distance there is actually equal to 11.47959 there. So in this case, the distance between point A, between point B and in this case A, so in this case, the distance between those 2 points simply be equal to that distance there, right, which would be that plus this one there. So in this case, what I'm simply going to do would be to say that distance in this case between, let me just say between a point B and D, so simply be equals to 11.47959 plus, in this case, plus 11.47, in this case, that's 47041, simply be equal to, if you put that into your calculator, all of it, you're actually going to get, in this case, 22.95 meters. So that would be how you'd actually have gotten that 7 marks there. So in this case, what we are going to do, let's just look at the final one. So they said that in this case, for 1.4, they said that sketch a velocity versus time graph in the answer book. Now, unfortunately, we don't have the answer book. They said that for the motion of ball A from the time it is projected until it hits the ground, they said that clearly show the following on your graph: the initial velocity, the time it takes to reach its maximum height, the time it takes to return to its starting point. So in this case, what I'm simply going to do would be to say, now you must write the velocity versus time. Right, so in this case, what I'm simply going to do there would be to say, now let me just put it maybe down there. Right, so in this case, simply in this case, be velocity in meters per second. Right, this will simply be in this case delta t in seconds. So in this case, we know that of course this object was projected with the velocity of 15. So in this case, it's gonna start with the velocity in this case of 15, right? At that point there, this would be velocity 15. So in this case, what would happen is that in this case, as this object is in motion, right, on its way up, so in this case its speed or this velocity was decreasing in this case until it became 0, right, at the maximum height. In this case, after it reached the maximum height, it continued. In this case, it started traveling in the opposite direction, passing where it started, right? In this case, that's actually what they wanted there. So in this case, so this would simply be 15. So in this case, when it returns to in this case to where it started, so in this case the velocity there would simply be in this case negative 15. So that's a 0 mark there. So in this case, this would be the time, how long it took to in this case to reach the maximum height, which would be that we said that's 1.53. So in this case, it reached at that point there at time, which is 3.06. So that's how you would actually get also those 4 marks, right? I think the marks would actually come for labeling and of course putting those values there. So in this case, you must always, that when they ask for the velocity versus time graph, you must actually just label that in this case the y axis is actually the velocity and the axis is actually the time, and also the SI units. But yeah, otherwise, ladies and gentlemen, this is the end of this question paper. Right, so if you have any questions, you are more than welcome to ask in the comment section, or if you have any topic that you'd like me to cover, you can just throw that in the comment section. So if of course this video helped you at some extent, be sure to leave a like. But otherwise, it's